Here we have a basic React.js application, and even in such a simple application, we can demonstrate a bit of the great developer experience offered to React development by using TypeScript. First up is autocomplete. TypeScript suggests and autocompletes the component name for us. It also autocompletes any component props. Next up is type checking. Misspell any component name and TypeScript gives us a nice error. Misspelling any component prop also gives you an immediate error. Forget to provide a required prop and you also get an error. Provide a value of the wrong type by mistake and you get a nice error. With this active compile time error analysis, you get a lot less runtime issues in your codebase. As developers, we spend a large chunk of our time refactoring existing code. TypeScript is an ideal tool for refactoring. TypeScript makes it easy to rename a component to something that makes more sense as you understand more of your business requirements. And this is not a dumb string search and replace. This is true semantic rename. You can also easily rename any prop in your component. And as requirements change and you add new props, users of your components get nice errors. Later on, if you decide that you need to change the type of a prop, that is pointed out to your component users as well, thanks to TypeScript. These are just some of the refactoring advantages offered by TypeScript. TypeScript also enables excellent code navigation for your applications. With one simple command, I can find all the references to the hello component. Similarly, I can easily see how any of the props for the component are used, for example, the compiler prop. TypeScript really enables a whole new level of developer productivity for React developers, and in this course, we will explore this simple TypeScript React combination. We'll start off with the bare bones package.json file. We'll go ahead and install all the modules we will need in one go. These are the general React modules like React, React DOM, Webpack, Webpack CLI, Webpack Dev Server, along with TypeScript and TypeScript specific things like the types for React, React DOM, and TS Loader for Webpack. Once the installation is complete, let's kick off by wrapping up all the modifications needed for package.json by simply adding two script targets. We add a build script which just invokes Webpack in production mode. We also add a start script which runs the Webpack dev server for live application development using development mode and serves up the public folder. Next, we will go ahead and add a webpack.config.js configuration file. First, we specify the application entry point. Up next is the output location for our built bundle. Next, we tell Webpack to support TS and TSX file extensions along with the original JS extension. Finally, we tell Webpack that for TS and TSX files, it should use TS Loader. Next, we will go ahead and create our basic HTML file in the public folder. This file simply contains a root div where we will render our React application and then loads the bundle generated from Webpack. Next, we go ahead and add a tsconfig.json file to set up the TypeScript compiler options. We enable source maps so we can debug the TypeScript files. We will be transpiling to CommonJS. We want our JS to be compatible with ES5. For JSX, we will be using React. We include all the files in the source folder and disable compile on save for the IDE, as that will be done with Webpack. That's it for the configuration. Now let's write some demo code. I'll create a source app.tsx file. We'll simply import React and React DOM. Finally, we use React DOM to render Hello World to our root div. Now if we open up the terminal and run our script target npm start, it will start up a Webpack dev server and serve the public folder up at localhost 8080. If you visit this URL at the browser, you can see our application running. If you make an edit to the file, Webpack dev server will compile the file on the fly and reload the browser. Now when you are ready to deploy your application, you can execute npm run build. This time, Webpack will compile our code and write the app.js file to disk. If we wanted, we could ship the whole public folder to some hosting service provider, as it contains the build file along with index.html. To recap, the setup simply involves three simple things: package.json for specifying our npm modules and scripts, tsconfig.json for configuring TypeScript, webpack.config.js to use Webpack for compiling and running our code and npm modules in the browser. Here I have a simple TypeScript application that renders the div Hello World to the DOM using React and React DOM. We can easily move this div into a stateless component called app by creating a function called app and returning the same JSX element. Of course, one big advantage of components is that you get to use props to change the component behavior. For example, we can take the message as a prop by adding it as an argument and using it inside the function body. TypeScript tells us that this property needs to be provided, so we go ahead and provide it. And let's add something different this time. You can see that it works as expected. Although such simple functions work fine for stateless components, if you want to create high-quality TypeScript components, it is recommended that you annotate such functions as React SFC. The React SFC interface takes a generic argument that allows you to easily provide the type annotation for the component props. You can see that the type specified over here flows through to the function arguments. Of course, if you want, you can easily move out this inline prop type definition into an appropriately named type. For example, app props. Here I have a simple TypeScript application that renders the div Hello World to the DOM using React and React DOM. We can easily move this div into a stateful component called app by creating a class called app that extends from react.component. Within the render function, we return the JSX element as before. And you can see that it works as expected. Of course, one big advantage of using components is that you get to use props to change the component behavior. React.component takes props as its first generic argument. Let's go ahead and add a prop with the member message of type string. We can use this prop in our render method. As you can see, TypeScript is already complaining about the component being used without providing the required message prop. Let's fix this by passing in a new message. And you can see that this prop is now used. Components that extend from React.component are called stateful because they can have their own internal state. React.component takes a second generic argument which specifies the type of the state. Let's go ahead and set up our state with a count of type number. We can initialize the state in our constructor. When adding a constructor to a React component, you get past the initial props, which we simply pass to the super React.component class. Now we set up our initial state to have a count of 0. Finally, we can use this state in other places like the render method. And if we run this example, the initial value of the state shows up as expected. The key reason for having local state in a component is that you get to manage it inside the component. For example, we can call an increment member function whenever the root div is clicked. Within the increment function, we simply use the parent React component's setState method to increment the count of the current state. And if we go ahead and click the div, you can see that the state changes correctly, causing the component to re-render with the new state. Of course, if you want, you can easily move out the inline type definitions for props and state into appropriately named types. Here we have a simple bare bones package.json for a node module which we have named Fancy. We start off by installing TypeScript, React, and the type definitions for React as dev dependencies. We add these only as dev dependencies as we want people that will use our package to bring in their own versions for these libraries. Next, we create a simple tsconfig.json file to specify the TypeScript options. Within our file, we specify the compiler options for source map, target, JSX, along with declarations which we set to true, and most importantly, the output directory for the compiled JavaScript and declaration files using outdir. We also specify that our source TypeScript files will be in the source folder. Next, we simply create our root source index.tsx file. Within the file, we bring in React. Next, we export a simple Fancy component that takes a text prop as a string and renders it into an h1 tag. We wrap up our module by making the final set of changes in package.json. We add a hint for our users that they need to provide their own version of React by adding it to our peer dependencies. We set up package.json with the path to our output JavaScript files along with the types for the output d.ts TypeScript declaration files, which in our case is specified by the outdir and hence the lib folder. We also set up a build script which simply invokes TSA, the TypeScript compiler, on our tsconfig.json. Add a start script that runs build in watch mode for live development. Now let's go ahead and run build once on our console to compile our project. At this point, if you wanted, you could run npm publish to publish this library to npm, but we will just use it locally by running npm link. Now let's jump back to our good old Hello World React application and use this Fancy package. If we had published our package to npm, we could use it with npm install Fancy. But since we only linked it locally, we can bring it in by running npm link Fancy. This npm link workflow is also a good tool to be aware of for local testing of packages before deploying them to npm. We start off with the simple, basic TypeScript Hello World React app. We now import the Fancy component into our application. Of course, since the Fancy package was written with TypeScript, we get nice autocomplete, error checking, and all the other benefits we demonstrated in the first lesson. As you can see, our fancy component works as expected. We start off by installing Jest, the types for Jest, the TS preprocessor for Jest, enzyme, the types for enzyme, the enzyme adapter for our React version, and we save them to our dev dependencies in our simple example React TypeScript application. Jest is configured using a jest.config.js file. So we'll go ahead to the root of our project and create this file. Within this file, we will go ahead and specify our root directory to be the source folder. We will tell Jest to use tsjest for ts and tsx files. We will go ahead and specify how Jest should look for test files. For example, it will look for .test.tsx files and consider them as tests. We will specify the module extensions ts and tsx along with the defaults so that Jest can look up TypeScript files. Finally, we will go ahead and create a setup script target for enzyme. Of course, now we should go ahead and create this setup script file. So we will go to our source folder and create a file called setupenzyme.ts. Within the file, it's fairly boilerplate. We go ahead and get configure from enzyme. We load the enzyme adapter for React 16. And finally, we configure enzyme to use this React 16 adapter for our project. And that's pretty much it for setting up Jest and enzyme. It's simply a matter of installing a few packages, creating a jest.config.js, and setting up the enzyme configuration. So let's look at a simple checkbox with a label component. We will bring in the usual suspects. We will bring in React. We will create a new class, checkbox with label, that extends react.component. It takes a few props, a label on string, a label off string, and then it has a local state is checked boolean, which it will manage based on user interaction. We go ahead and initialize the state in the constructor. Then in onChange, we will toggle the isChecked state. And then finally, within the render, we will go ahead and return an input wrapped in a label. The input's checked state will be managed by the state. Its onChange will pipe to our onChange function. And finally, we will use the isChecked state to show the label on or the label off prop. Now let's go ahead and understand this component a bit better by demonstrating it in a real application. So we will jump to our application entry point app.tsx. Within that file, we will go ahead and bring in this component and use React DOM to render this component with on and off props to the document root. We can start this application with npm start from the terminal. And with the application running, I can go over to my browser and interact with the component to demonstrate that it works as expected. Components with internal state and DOM-based interactions are exactly what enzyme is designed to test. So we will go ahead and create a checkbox with labeled.test file. We will bring in shallow from enzyme. We will bring in our component. And we'll go ahead and create a basic Jest test. Within the test body, we will use enzyme to do a shallow rendering of the checkbox with label component. We can use this checkbox variable to do DOM interactions with the component. For example, we can get its text, make sure it's equal to a particular value. We can find a particular DOM element, for example, input inside of it, trigger a change, and then we can expect the new value to change based on that interaction. Now there are quite a few ways you can configure Jest run. But if you have Jest installed into your package, you can use npm's new command called npx by running Jest from your root folder. and it will go ahead and run all the test files. Here we only have one test file, and you can see that it works as expected and the tests pass because the text of the component changes based on user interaction. We start off with a very bare bones TypeScript React application. We have a checkbox with label component that we render to the root element in the DOM. The component takes an ID, an on label, and an off label. If we go ahead and start the application and visit localhost 8080, you can see the application running. The checkbox starts with an off state and we can trigger it on with a click. Now let's add a real browser test for this behavior using Cypress. We will go ahead and make a separate directory for Cypress. In that directory, we will go ahead and initialize a new package.json and then install Cypress as well as any tools Cypress needs to transpile TypeScript code on the fly using Webpack. Of course, Webpack, TypeScript, and tsloader are the obvious things that we are installing here. Next, we open the Cypress IDE using Cypress open. This will initialize the Cypress folder structure for us. To configure Cypress for TypeScript, we will go into the Cypress plugins index.js file and replace whatever is present there with a Webpack TypeScript preprocessor. This is provided by the Cypress Webpack preprocessor, and we simply need to initialize it to use tsloader. The Webpack options here are the standard webpack.config options for TypeScript and TSX. We will set it to mode transpile only, as we do not want this to do any type checking, to save us some speed. Finally, we wire this preprocessor to the file preprocessor event in Cypress. We will go ahead and add a separate tsconfig.json to this folder. Keeping the tsconfig for the E2E tests separate from our project code prevents global type definition conflicts, for example, describe and it. All the testing frameworks tend to use the same names, and they are all in the global namespace, so it's best to keep Cypress separate from their pollution. The config options will be very similar to what you have in the root of your project. Optionally, we can go ahead and add a few script targets to our package.json. One would be for development, which will simply run Cypress open, and the other would be Cypress run for the build server. That's it for the configuration. Note that at this point, this E2E folder is primed to be copy-pasted into any TypeScript React project you want, and it doesn't depend upon our project in any way whatsoever. Now let's write some tests. All the Cypress tests exist in the integration folder. It comes with a few examples and we can safely delete that. We'll go ahead and create a new happyspec.ts file for our test. We will reference the Cypress type definitions and we will create a happy path test that should work. Initially, we'll simply visit the server that we have running using npm start. If we go to the terminal and run the Cypress IDE using Cypress open, we can see that our test is present, and clicking on it goes ahead and runs the test. You can see that the test passes. At this point, it is only visiting localhost 8080 using the sci.visit command. The next step is to assert the text of the root label, then trigger a click on it, and then assert that its text changes. We can get a handle to the root label using the Cypress inspector. It tells us that it has the ID on off, and we can use sci.get to get it. We can copy this and paste it directly into our test. We can make assertions using the should command provided by Cypress and passing in the chain have text, and it should have the value of. And then we go ahead and trigger a click using a click command, and then we make an assertion that it should have text on. Now as soon as we save this file, Cypress is going to rerun the test in the background, and we can actually go ahead and view the snapshot of the DOM as the test was running. We visited the page, then we got the element, asserted its text, and finally we triggered a click and asserted its text to change to the new value. If we want, we can also go ahead and rerun the test to see it unfold in front of our eyes. Finally, we can go ahead and make our tests more deterministic by sharing the code like the constants between our application and the tests. We'll go ahead and create a new constants file in the source folder. We will isolate the ID for the root label along with the text for the two options. Next, we jump into the application root and use these constant values to power our application. And we can go to our test file and use the same constants file from the source directory to bring in these constant values and use them to power our tests. You can see that the test continues to work as expected. Now if we go ahead and change something, for example, capitalize the on and the off text, the test continues to work and we didn't have to edit any of the other files. This works thanks to the way we set up Cypress to use Webpack and TypeScript. Finally, on the build server, you can execute the tests using Cypress run. This runs the tests in a CI-friendly manner without prompts and window interactions.